Decals, flows and trim sheets can be created from the Bake Geometry tool in DecalMaster. We're going to start with creating a decal. First, it's important to start with a simple plane that is 1 unit in size and located at the origin of the scene. This ensures the plane will cover the entire UV space of the baked textures. Notice that I'm insetting the decal as opposed to embossing it. This is because parallax occlusion mapping looks much better when displaying indented surface details than it does with protruding ones. I recommend never leaving any faces perfectly vertical, otherwise they won't be captured by the bake camera. Also, it's a good idea to bevel edges to better capture highlights. After you've modeled your geometry, you're ready to bake. You have the option to overwrite an existing decal by typing its name into the field or leaving the field empty to create a new decal. You also have the option to either create a new decal library or insert the decal into an existing one. Once you've decided on the name and library, click on the Bake Decal button. Depending on your bake quality settings, it can take anywhere from a few seconds to several minutes for all the textures to be baked. You can view the progress in the bottom left corner. A notice will be posted in the command bar once the baking is complete. It's recommended to bake at default settings initially and then place the decal to spot any issues with the geometry before going ahead with a higher quality bake. If you notice shading artifacts on the decal, you can simply perform a smooth operation on the bake geometry to remove them. Everything looks fine. It's very simple to add subset details to a decal. All you need to do is create separate objects on top of the main object. You can see I'm performing smooth operations on the objects here to remove shading artifacts. Let's go into the settings. The quality slider alters how many rays Arnold casts into the scene, making for crisper edges and less noise throughout the texture maps. This setting can greatly increase baking times. Some texture maps benefit from 16-bit depth because they are used in floating point calculations for lighting or surface information, like the normal map, curvature map and the AO map. Smoothing determines the radius of pixels that are being blended together. It should be kept at a low number as it does increase baking times, but it can be useful to reduce jagged edges and noise, especially between the main and subset objects. AO samples determines how many rays are cast. Ambient occlusion requires a large amount of rays to avoid a noisy result, but this setting can greatly increase baking time, so it's best to leave it low until you do a final bake. You also have the option to alter the contrast in the AO map to flatten the values if the AO is too strong, or increase the AO to make subtle details pop out. Curvature samples lets you control the ray count used. Like the AO map, the curvature map requires a large amount of rays to avoid a very noisy result. The curvature map radius represents the radius of pixels a curve affects. Higher values lead to wider and softer curvature lines. If the decal extends upward beyond 1 unit in the y-axis, it will be clipped by the baking camera, although that should never be the case, as that would cause the parallax effect to look very poor. Regardless, the height map distance allows you to ensure the entire decal is captured without clipping. Height map contrast directly alters the parallax effect. It allows you to exaggerate or reduce the vertical distance of a decal. When you're ready to bake the decal with subsets, select all subset objects first, then the main object last. The main object should be highlighted green. You can cycle the subset material to make sure it was baked properly. Notice how there is an alpha mask blending the edges. There should always be at least a small amount of padding for the alpha mask to achieve the best blending into the decal. The alpha area is determined by the uppermost outside faces that are flat. It is important that the outside faces are perfectly flattened to ensure they are recognized by the alpha mask. As with simple decals, you can also bake repeating decals, otherwise known as flows. They are largely identical to simple decals, but there are some important differences to consider when baking. First, flows will always repeat along the x-axis, so make sure the repetition is horizontal and not vertical along the z-axis. Like decals, you should start with a plane that is 1 unit in size. However, because flows are meant to repeat, it is very important to extend the faces along the x-axis by around 1/10 of its size to avoid any lighting artifacts in the texture maps. Flows are designed to enable transitions between two different surfaces. They do this by utilizing a material mask in the same way as the subset material does. This is called material 2. Currently the separation between material 1 and 2 is along the x-axis. In the future you'll be able to guide the material masking. Flows are not just limited to material 1 and 2 either, they also support subset materials. Just like with decals, make sure to select the main object last. The subset objects should be highlighted white and the main object green. You may need to manually match materials 1 and 2. Finally, we have trim sheets. Trim sheets are essentially a collection of repeating and non-repeating decals, and so their baking process is no different than decals. First, start with a unit plane centered at the scene origin. This is a simple example to demonstrate modeling and baking a trim sheet. In practice, choosing the layout and scales of the trims in a trim sheet is equally as important as the modeling of the trims to ensure a uniform textile density. It's important to leave a small amount of padding for each trim, although only vertical padding for repeating trims, as they must horizontally span the entire plane. And just like decals, you should indent surface details as opposed to protrude them. Avoid any perfectly vertical faces and bevel edges to get the best results. Like decals, trim sheets utilize the subset mask to enable multi-material details. Again, simply select the main object last. After you've finished modeling the trim sheet, it's time to bake. When choosing the trim sheet resolution, it is important to account for the difference a trim's fraction of UV space is within a trim sheet compared to a decal taking the entire UV space, so you'll want to select a higher resolution than you would with a decal. You can either select an existing trim sheet to overwrite if you're making edits, or type in a new trim sheet name. Now that you've baked the trim sheet, the final step before being able to use it in DecalMaster is to create a library from the sheet textures. You can do this through the Trim Sheet Editor tool. If you haven't yet done so, I recommend watching the tutorial video on creating a trim sheet library.